All right, let's look at the homework 14.8, problem number 4. All right, so let's take the gradient of f and set that equal to gradient of g times lambda, and where this guy is g of x comma y comma z. All right, so let's do that. So first partial with respect to x is going to be 2x, then y squared, and the z squared is just a constant, is equal to, and you have a 2x times lambda. All right, and the partial with respect to y would be 2y x squared, and the y squared is equal to 2y lambda. All right, then last one with respect to z, so 2z, then you have a x squared and a y squared. Actually, I messed it up here. All right, so this is going to be a z squared. All right, z squared, and this is going to be equal to 2z times lambda. All right, then here, first thing I would do is I'm going to just divide through by 2. So divide through by 2 here, and divide through by 2, and divide through by 2. All right, then I'm going to do this. I'm going to multiply this one by x. So we get, actually, I'm going to do it right here. All right, so I'm going to just multiply by x. So you're going to get x squared, and here's the x squared, right? And I'm going to multiply the second one by y, so it's a y squared, and here's a y squared. And I'm going to multiply the last one with z squared, so it's going to be z squared, and then you have a z squared. All right, so now all three of them is x squared times y squared plus z squared, so we can get this x squared times lambda is equal to lambda y squared, and that's equal to lambda z squared. All right, so if lambda is not equal to 0, then we can divide these guys through. So by lambda, so it's going to be x squared is equal to y squared. That's equal to z squared. Right? So everyone has this basically the same magnitude. The sign might be different. So you can see that if you plug it into this g function, and you're going to get x squared, and y squared is the same thing as x squared, and a z squared is also same as x squared, and that's equal to 1, right? So actually, why don't I go ahead and add them up? So you have a 3x squared squared is equal to 1, which means that divide through by 3, you have x squared is equal to 1/3, right? And also, this is the same as y squared and also z squared, right? So what happens to this function? So this means that the f value, right? So there are actually quite a few points, total of 8 points, because this is going to, each one will give you plus or minus square root of 1/3. And a y is going to be plus or minus square root of 1/3, and so on, right? So, but all of them will give you exactly the same corresponding f value, because you're multiplying by right, x squared, which is 1/3, and y squared would be 1/3, and the z squared would be 1/3. So this is going to be just a 1/27. right? So that's going to be one value. The value at there are actually 8 different places, because you have choices, 2 choices for x, 2 choices for y, and 2 choices for z. So 2 to the 3rd power. So there are 8 points that will give you 1/27. All right. So remember that we assume that this is the case when a lambda is not equal to 0. What if lambda is equal to 0? Right? So if lambda is equal to 0, then funny thing happens, right? So you can see that this is going to give you x squared times y squared times z squared is equal to 0, right? So which means that this is going to be either x is 0 or y is 0 or z is 0, right? But we don't really worry about the details, but we know that the x squared, y squared, z squared is equal to 0. That's actually the same f function, so that's the value of f. Right, so you have some points where one of the variable is equal to 0. Then of course the whole function becomes 0. And there are 8 other points that gives you the value of 1/27. Obviously 1/27 is larger than 0, so 0 is the minimum value, and 1/27 is the maximum value. All right, so let's type it in. All right, we got, let's see, we got 1/27. I think that's what we got there. And the minimum value is 0. All right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.